Ah lads, right, thought I'd show you my latest acquisition, well toys if you like. These are 1.8 kilowatt AC brushless servos. They're from BST Automation on AliExpress, or better known as Fredly, and they're going to go on the big milling machine that you'll see in my thread that this video will be posted in. They're going to replace some big DC brushed SEM motors, so that's why the 1.8 kilowatt, they're quite a beefy motor. Right, first impressions out the box and setting them up, very good. I'm quite used to testing motors, drives, controllers, various different companies' products, and when you're doing that you tend to get a feeling when you're setting them up, when you get them out of the boxes and wiring them up and setting them up, you tend to get a feeling to how they're going to go in use, and often I would say 95% of the time that first initial contact follows through to the end when you're using them. So if you get a good first initial contact, it tends to be a good relationship you have with them working, and I've had a good first contact with this. I've got that nice warm fuzzy feeling, so I'm quite pleased in that respect. It could all change when they end up on the machine, but at the price range, or the price I've paid for them, I'm prepared to take that gamble, and believe me, they're really cheap. I will tell you how much in a bit. Anyway, I bought 3 sets of them, and I'll just show you what the come package like. Nice, the motors come in a nice sturdy polystyrene box. They have a lid, matching lid. They come in a bag. They've got silica gel in for moisture. I'm pleasantly surprised at how well finished these motors are, considering the price I've paid again. Like I say, really well finished. The encoder cover at the back, it's not plastic. You'd expect a plastic cover on at this price range, but it's not. It's very well sealed, or rubber sealed on the head where the mount, where it meets the back. All the encoder connectors are sealed up. They're nice, sturdy, they're not plastic. Again, you might expect plastic on these things at this sort of money. All the shafts sealed up when it enters. It's got a nice size shaft. It's 19mm with a 5mm keyway in it. Provide the key as well. This particular motor is a 110 frame, so it's 110mm across there. It's the equivalent to, say, like a NEMA 42. It's about 10 inch long in length. It's a big motor. Give you an idea of just how big it is. That's a NEMA 23 stepper motor at the side of it. That's a NEMA 34 stepper motor at the side of it. As you can see, it's quite a big motor. You might use something like that, although slightly more powerful, on a milling machine, on a small bench mounted milling machine, but so it gives you some idea of the size of the machine that thing's going to go on. It's big. Right, packaging for the drive. The drive comes cardboard box, reasonably well protected as well, and then all this lot came inside another cardboard box. Well, there were 3, because I've got 3 sets. I got 3 motors in one box, 3 drives in another box, and then the encoder cables came in another separate box. Came in 3 packages. Zoom in slowly here. The drive can take single phase or 3-phase input, and it says 220 volts on it, but it's actually programmable within the drive. You can go up to 250 volts, I believe. It's got a 30 amp rating, so it can power some quite big motors, can this drive. The manual actually says it will do up to 7.5 kilowatt, which sounds a bit big to me, but anyway, that's what it says. I'm sure it'll be more than enough for this 1.8 kilowatt. that sticker just relates to the motor. Right, the motor, if I can slowly zoom in. I'm using a mobile phone here, so it's not the fastest to react. I'm trying to focus on that sticker. I think you can maybe work it out there. It's 3000 RPM. That's its rated speed. It will actually go, it will do 5000 RPM. The drive will have it run to a maximum of 5, but it's rated at 3, and 6 Newton meters of torque at 3000 RPM. That's its continuous rating, and it will pull 6 amps. Peak ratings are something like 22 Newton meters of torque, and something like 20 amps. It will pull for so many seconds at peak. So let's say you've got the motor under a heavy load, so you're accelerating or deaccelerating the table with a big heavy load on it, and you need that extra oomph, then it will give you up to 22 Newton meters of torque for 20 seconds or 30 seconds or something like that, enough to hold it for slowing it down or giving it that initial kick up the arse to get it going. So like I said, decent size motor. It's got 2500 line encoders on it, incremental encoders, which they are quadrature encoders, which means that's 10,000 pulses per revolution of the motor shaft. So it's a decent resolution, a lot higher than you would have on the stepper system. The drive is also, it's possible to use electronic gearing. So for instance, if your controller that you're using hasn't got a very high frequency, so let's say it's only 25 kilohertz, so you're restricted on how many pulses you can put out, then you can still get the full speed from the motor, because it's the pulses that your controller puts out that determine how fast your motor can go. Now if you've not got enough pulses, then you're only going to get, I would imagine, 25 kilohertz. You'll be lucky to get 1000 RPM out of this motor. So you can apply a ratio in the drive, so basically one pulse coming in equals, I think it's got a maximum of 5-to-1 ratio, so 1 in would give 5 out, so then you can reach your speed if you need to. The cost of doing that is you lose the resolution of your encoder, so if it's a 5-to-1, your 10,000 pulses gets divided by 5, and that's your maximum resolution. So the higher the encoder count, the more resolution you've got after you've geared it. So it's quite a flexible system, really. I'll be running it the full. I'm gonna run it on a analog controller. That's a CS Labs IPA controller. I'm running it on that. Now the drive itself will take step and direction or not, plus or minus 10 volt analog input, so it's very flexible. You can use it both. It's basically got 3 modes of operation: position, speed or torque. Now with step and direction you just use the position. Because I'm using analog, I'm going to use the speed mode. It's actually also programmable. You can use the inputs, and I could have it flip-flop between torque or speed just by setting one of the inputs, which I won't do, but I could if I wanted to do. Like I say, the kit comes with a set of encoder cables. You can see them at the back wrapped up. They actually come like that, packaged up. The cables are all made up with the exception of one cable, which you have to make up yourself, the input cable, which is this one, which, I'll be honest with you, to me this is the single feature of the setup that lets it down a little bit. I don't like this setup. I much prefer terminal strips like this, but at this sort of money you can't have everything. I've just stacked it together to get it working. When it's finished, it'll look just like this. This one, by the way, is for the encoder cable that goes to the motor, and like I said, they're all made up for you. This is the power that goes to the motor, and they're all made up for you. You don't have to crimp those on yourself. They come like that. If I lift this little flap up, this is basically the power in and out. So you've got your single phase going in there, and your 3 phases coming out to your motor. There's 2 of those connections are for a braking resistor. The third one is if you've got 3-phase input. So your first 3 wires will be the 3 phases. The last 3 is the 3 phases out, and that's for your braking resistor. A braking resistor is what you would use if you've got an heavy load. Let's say you've got a table that was quite heavy and you're wanting to accelerate or deaccelerate the machine quite hard, then that will feed back a certain amount of current and back into the drive. Now the drive's can deal with so much, but there is a limit depending on the load it's trying to bring to a stop. And if it gets past a certain threshold, then if you haven't got a braking resistor, the drive will trip. So to avoid that, you put a braking resistor on, and you do a little calculation. You size that resistor to the load that the maximum load you think you're going to be trying to stop, and that will dump the power to the resistor, and then you don't get a trip. So got that on it, and then the other connections, I've got the earths going to the body of the frame. The drive, 2 ways you can mount it. You've got little brackets top and bottom for mounting it in the cabinet. Like I said, typical Chinese quality electronics, really. Works very much like a VFD. You've got parameters, different types. It's sort of the DN, that is for to display various outputs of what the drive's doing. So let's say you wanted to see the voltage it was pulling, you choose one of the modes and it'll show you the voltage, it'll show you the current, it'll show you the encoder count, various display modes. FN is function modes. Function modes being jog. You could, if I didn't have a controller connected to the system, we can still control and jog the motor using a jogging function within the drive using the keys. There's various other functions. And then PN is all your parameters for setting the drive up, which to be honest with you, it's a bit like a VFD. You've got an absolute load of parameters that you can change if you want to change, if you want to delve into it. Numerous things you can change about it, speed curves, God knows what else. But you don't have to if you don't want to. And it's actually, surprisingly, how easy it was to set up. The motors come. Oh, by the way, you don't get a paper manual with it. It's just a PDF. It's a typical Chinese PDF, if I'm honest with you. You've got to read it a good few times to get your head around it. Bit of translation. Work out what they're trying to tell you. But it's got everything inside it you need to know. Now, one of the parameters is each motor has got a code. So the code for this particular motor is 15, so I enter 15 in one of the parameters, and that then sets the drive up to that motor, so the drive knows what motor it's dealing with. Now, if you was using a step and direction controller, that is the only parameter you would have to change, and the motor's working. I'm using CS Labs analog controller, 0 to 10 volt, plus or minus 10 volt. So I've got to change a few more parameters to make that work. Plus I've also got encoder feedback coming out. That's the encoder input coming from the motor, so that keeps the closed loop system closed between the motor and the drive. That is what that's doing, but I want to extend the loop back to the controller. So basically I've got an encoder feedback coming out of the drive to my what they call upper controller, so which means I've got a little bit more feedback to Mat 3 basically. I'll show you what that means in a minute. You've also got your inputs and outputs on this connector, so some of the inputs are like, one input is to enable the drive, another input would be to reset the drive if you'd had a fault, and then you've got outputs, so like if you did have a fault it would output to your controller so the controller could stop, because it knows you've got a fault happened on the drive. And the inputs and outputs are programmable, you can have them do various jobs. So it's quite a flexible drive in that respect. It's got all the features a lot of the higher spec drives have, so it's not limited in what it can do. It's quite sophisticated in what it can do. Right, I'm trying to think what to tell you. I suppose I'll tell you the price of them, that'd help. For drive, motor and all the cables, including delivery to UK, it's cost me £300 for one set. In total I bought 3 sets and that was £850, not US dollars, pounds, delivered, and then I had about £50 worth of import to pay, so it cost me £904 in total. That is for 3 sets of motors, drives and encoder cables, all delivered in 5 days. From ordering to delivery, 5 days, which is amazing. So you can see why I keep bleating on about the price. Bearing in mind, just one motor, not talking about the drive or the encoder cables, just one motor from or one motor that size, so a 1.8 kilowatt motor from a branded name, and even not an high-end brand name, just what I would class as a medium brand name, you would be paying probably £1,000 just for the one motor. I've got all 3 motors, all 3 drives, everything for 900 quid. So now you can see why I'm bleating on about the price, because I've just got to take a chance really. You've got to accept that and take your chance. I can get through quite a few sets before I end up paying the same money as one decent branded name, so it's a risk I'm prepared to take. So and like I said, the warm fuzzy feeling so far, it's still there and they're working good. Right, I better show you working then, seeing I've said they're working good. I've got Mac set up just to whiz them backwards and forwards. That's 3000 RPM. You can see the screen whizzing round. And, it's tuned at something like 15 meters a minute, something like that. What can I say? Right, like I said, nice motor. They're a nice smooth action. You can see it's just sat on the bench there, and it's quite a big motor, that, with a big rotor, so there's quite a bit of inertia on that rotor, so at that speed you can see that they're a relatively smooth motor, because it's not jumping about too much to say it's such a big motor. If I jerk it with the acceleration, yeah, I can rock it about, but in general it's quite good. Very accurate, so if I send this back to 0 now, you will see, and we're back to where we started. Max DRL showing 0, and show you we're back. So now the reason why I use an analog controller is I want feedback right up to Mac, so I'll show you why that is. If I take Mac out of reset, so basically put it in e-stop mode, when I do that, it sends a signal to the drive and it disables the drive. So now I can turn the motor shaft by hand. It's a bit like a stepper system, powering down, turning the drive off on a stepper system. You've got control of the motor. Now I'm turning that, and as I turn that shaft you can see Mac's updating the encoder, the DROs, even though the drive's turned off and Mac's not in control of the motor anymore. It knows exactly where the motor is. So the effect of that means I can actually use the machine as like a manual machine with an electronic DRO on it. It also means Mac never gets lost. So for instance, if this was a stepper system and you put Mac in e-stop and then manually push the gantry or one of the axes, when you reset Mac and turn Mac back on, Mac still thinks it's in a different place to where the machine would be. So you're lost in effect until you own the machine. You're out of position. Now that's not the case. Now if I reset Mac, you can see the motor there is out of position. Mac's DRO is displaying the position it's at. It's at 4.19. If I just tell Mac to go back to 0, and you'll see the shaft go back to 0. Alright, the shaft's gone back to 0. Mac's gone back to 0. So it knows exactly where it is at all times. It doesn't get lost. So it effectively means you don't have to own the machine after you've stopped it in an e-stop or something like that, because you're not lost. Mac knows where it is because it's reading the encoder, and the encoder displays how many times the motor shaft's turned. So that is why I have the encoder feedback. Now most step and direction controllers don't give you that option, to be honest, whereas the analog controllers, you actually need that feedback for them to work, because one of the steps I have to take with the analog controller that you wouldn't with step and direction is I have to tune the controller to the motor using what's called PID tuning, which sets it up for basically how it handles the torque on the shaft. So when this motor first came and I first plugged it in, this motor's sat nice and steady now, but when I first turned it on and before it was tuned, the bloody thing was dancing all over the place. It didn't know where it was or what it was doing. It got a right head shake. It was giving it this. So I had to set it up, and I will have to set it up again when it goes on the machine. It will all change because the PID tuning is all sensitive to the load on the shaft, the resonance of the motor, and how it's on the machine. So if it's stiff on the machine, it will affect how it's tuned. So when it goes on the machine and it's working state, I'll have all that to do again. It's one extra step that can be fiddly and a little time consuming, but once it's done, and the feedback is worth the effort. It makes for a very accurate system. Right, I've got some code somewhere. I forgot to load it up, so just bear with me 1 second while I load my test file up. Right, this is just a bit of G-code to whiz the motor backwards and forwards. And that's, well, it was at full rapid speed. We've dropped to a GO speed, a G1's commanded feed rate now of 500 millimeters a minute, and you can see it's a nice smooth action. I'm not even going to attempt to try and grab that shaft and stop it because it'll just rip my hand off. You have to take my word that you're not going to stop that motor easily. It'll just do this for a minute or two. not too long, this code. As you can see there, those direction changes are at rapid speed, and the motor's not jumping around too much, so they're a smooth enough motor. The acceleration and deacceleration is okay, and I've actually got the acceleration set quite high, so it will be a lot smoother when it's working properly as well. And then also in the drive you can program an S-curve for the acceleration and deacceleration. I think at the minute it's just a linear curve, but you can program it to be an S-curve, so it will gradually speed up and slow down. I haven't looked into that, but I'm happy with it as it is. And there you go, it's finished. As you can see, it's back on the mark, and Mac's DRO's reading 0. And for those that are used to Mac, you'll have often seen Mac tends to always stick a number on the end there, so when you tell it to go to 0, it might sometimes not get to 0. It might be 0001 or 2. Well, when you've got the encoder on, that's not the case. If you tell it to go to a number, so if for instance if I go to the NDI and I enter in, say, GOX 56.8976, and I push enter, that's just made a liar of me. It's 8975, so you can see what I'm saying. It's still very accurate, but if I send it back to 0, we're back at 0. So yeah, that's it. That's what I'm going to put on that big mill. I'm showing this so people on my CNC can see it, but also anybody who might be thinking of buying some, they give you some idea. When they go on the machine, obviously I will report back, and if they're not as good as I hope they would be, if they give me any problems, you can bet your house on it, I'll tell you about it. So, but you've got to bear in mind, like I said, £300 doesn't buy you much, so if you're expecting the world, then you're expecting too much. You've got to accept a certain amount. Right then, cheers, see you later.